All right. Hi, guys. Welcome back. So, this is going to be our lesson on the size and scale of the universe. What you're going to need for this lesson is you're going to need your notebook pages, and you're going to need slides 22, 23, 24, and 25. And you're also actually, sorry, going to need slide 18 as well for Science Now. And in Science Now, we're going to be in the second row. So actually, let me go back to this. To get us started for Science Now, we're going to be working in our second row. And this is the week of 1028. And this is space lesson 2. And our question, I'm going to flip over to our slides here. And so our question to get you started this week is based off of the article Life Without Gravity and the discussion post that we did. And so for Science Now, I want you to imagine that NASA wants you to be a part of the first colony to live on the moon. Based on the article from last week about life in space and life without gravity, would you live in space? Would you want to live in space long term? And why or why not? And in your answer, think about the article again that we read and some of the different advantages and disadvantages of life without gravity, and cite those reasons in your answer. So go ahead and pause this video, take a couple of minutes to write down your answer, and you're going to come with that answer to our class meeting on Monday because I really want to hear what you guys have to say. Okay, so pause, write your answer, and then come right back. Okay, so now that you've had some time to write and brainstorm, our goal for this week and the goal of this lesson is to develop and use a model to understand the size of the universe and the objects in it. Now, the first part of this lesson is going to give you information about different types of objects. Oh, goodness gracious, I can't talk here. Hold on. It's going to give you information about different types of objects that are found in our universe. The web quest is really going to be then where you're going to be using different models and different types of scenarios to kind of help understand the size of the universe and some of the objects in it. I believe, if I remember correctly, the first thing that you have in your notes actually is a little blurb about gravity. And so to summarize what we did last week, we learned that gravity is the force that objects exert on each other because of their mass. And so every object in the universe that has gravity is going to exert a gravitational pull on every other object in the universe that has mass. And we learned that gravity is dependent on mass. So the more mass an object has, the more gravity it's going to have. Now, when we start to talk about the universe is basically everything in space. So anything that we can think of, it's a part of the universe. This is going to consist of all matter and all energy that is in our world. So the universe is pretty stinking big. And you can actually see here in this picture all of these little tiny objects. These are all galaxies. So, our galaxy is not the only galaxy. It's one of many. And when we think about how big our galaxy is, it's pretty amazing. Now, if you're curious or if you've wondered about, how did the universe come into existence? What the heck is going on there? The most widely accepted scientific explanation of how the universe came to be is the Big Bang Theory. And I've actually I've posted a video clip about that. There are other scientific theories out there about how the universe came into existence. And then throughout time, humans have always wondered this. So a lot of the mythologies that humans have, the stories that we have, are trying to explain how the universe came into existence. So we do have those. Now in science, we're focused on, what can we gather evidence for? What can we see? What can we obtain evidence for, maybe indirectly? So there are, again, several different scientific theories about how the universe came to be, but the most widely accepted one is the Big Bang Theory. So if you go back into Schoology, into our lesson, I have this little video clip linked for you guys. So check that out. Really interesting. It does give you a lot more information than you really need, but especially for you guys who really want to see the whole kind of big picture and details, there's a lot of really fascinating stuff there that you can really dig into. Okay, so carrying on now. From the next level in from the universe, we have galaxies. And galaxies are a group of millions or billions of stars held together by their own gravity. We live in a galaxy. It's called the Milky Way galaxy. And so everything that we see from Earth is located in our galaxy. So we can kind of think about, here is a picture of the Milky Way galaxy. This is a spiral galaxy. And we actually reside right here on one of the kind of like outer parts of this Milky Way galaxy. What's this giant thing right here? Well, this is a supermassive black hole that's at the center of our galaxy. And, don't freak out or anything. It's fine. But we're far enough away from this that we're not going to be sucked into this black hole. But we do have a supermassive black hole at the center of our galaxy. So pretty fascinating. And again, here's another video link for you guys. So if you want to pause this video, jump over, look at a little bit more about our galaxy, then that is there for you. Very fascinating. So moving in from galaxies, and by the way, there are many, many galaxies out there. And if you look at the picture that's in your notes about the galaxies, there's actually different types of galaxies out there. So if you're curious, check that out. Now, a solar system, our solar system, contains the sun, planets, and various objects. And so within the Milky Way galaxy, we are in a solar system that is revolving around the sun. And so we have some different planets here. We have other small objects that we're going to go through in your notes. And in our solar system, the sun is the only star. So it is larger than all of the planets in our solar system combined. It makes up 99% of the mass of the entire solar system. 99.9% of the entire mass of our solar system is the sun. So the sun is massive in relation to the rest of our solar system. We can kind of think about this: if Earth was a small bird, then it would be like the sun is like an elephant. And the sun is our main source of energy. The sun also serves as a source of light and warmth. So why do we have warm, sunny days? Well, it's because of the sun. And due to the massive size of the sun, and we can see now how massive the sun is in relation to the other planets. Due to its massive size, its pull of gravity is what's holding all of those planets in orbit around it. So there are actually 8 planets in our solar system that are going to be revolving around the sun. The sun is actually, however, considered an average-sized star compared to all of the other stars in other galaxies. So there are lots of other stars out there, and there are some stars that are smaller than our sun, but there are also a lot of stars out there that are a lot bigger than our sun. So the sun is really only average in size compared to stars in other galaxies. Now, a planet is considered to be a body that orbits a star. It is massive enough to be rounded by its own gravity. So basically, the idea here is that gravity is pulling everything toward the center. And because of that pull of gravity, planets take on a round shape. So if we imagine that this ping pong ball is a planet, they have their round shapes due to gravity. Planets are things that are large enough to clear its orbit of other objects, and planets are some kind of combination of rock, dust, and gases. So, like for instance, if we think about our planet Earth, we've got rock that make up Earth, we've got dust particles, and we also have an atmosphere. We have gases, and our atmosphere is primarily made up of nitrogen, oxygen, and some other gases, hydrogen, helium, those kinds of things. Now, different planets are going to have different compositions or different combinations of rock, dust, and gas, but those types of things are typical of planets. So here is a picture of the planets in our solar system, and you've got a space in your notes to write this down and record this. So Mercury is the planet that is closest to the sun, followed by Venus, and then Earth. So we're the third rock from the sun, if you will. Then Mars. And if you've been following NASA or following news in space, you know that we are, trying to get, eventually people out to Mars and see if we can establish, trips out to Mars and things like that. We've sent lots of different types of droids and explorers to look at the composition of Mars. Then after that, we have a big jump in size here. You can kind of see that, man, relative to Earth, Mars is actually a little smaller. Jupiter is substantially larger, followed by Saturn, then Uranus, and then Neptune. So 8 planets in our solar system. There are also many dwarf planets. Now, Pluto used to be considered a planet, and of course, people love, oh, Pluto. Pluto is considered a dwarf planet, so it's quite small, so not considered a planet proper. And, if you want to remember the order of the planets, one of the things that you can use is a mnemonic device. So my very excellent mother just served us nachos that can help you remember the order of these planets. Now, there are many planets out there that have moons, and we also refer to these things as satellites. And so there are lots of planets, Earth included, that have moons that orbit them. And so a moon is simply an object that orbits a more massive object. And there is a moon that orbits Jupiter called Titan. And it is an object in our universe that is the most similar to Earth. So interestingly enough, there in our solar system, it's actually a moon that's the most similar to Earth, not another planet. Now, some of the other things that can be found in our solar system are comets. These are small, icy objects that will orbit the sun. They produce what we call a coma, this thing that's coming off of it, a coma of gas and dust. And you can remember a comet is icy because the C in comet goes with the C in cold. They're known for their tail of light. Very beautiful. Other objects that can be found in our universe are meteors, and these are brief streaks of light produced by small particles that are going to enter Earth's atmosphere at a high speed. These will burn up in the Earth's atmosphere, and it's basically they're moving at a really high speed coming into Earth's atmosphere. Earth's atmosphere is filled with different types of gases, and there's basically a bunch of friction from the air that causes these things to burn up in Earth's atmosphere. And when it comes down to Earth's surface, if there's anything remaining and it falls on Earth's surface, then it's called a meteorite. We also have asteroids. Asteroids are small, solid, rocky bodies that orbit the sun. And so for the most part, these are found in a belt between Mars and Jupiter, and it's referred to as an asteroid belt. So we've just basically got these small rocks that are, orbiting within this belt between Mars and Jupiter. And so if you want to remember asteroids are rocks, you can remember that the R in asteroid goes with the R in rock. Moving further out, really weird word. It's called a Kuiper belt. This is a belt that lies beyond the orbit of Neptune. And there's basically just a whole bunch of stuff out here. It's got comets, asteroids, other small bodies of ice. There's 4 dwarf planets out here. And so this is basically just a whole area of space debris and objects that are outside the orbit of Neptune. Also, outside, even further past the Kuiper belt beyond Neptune is also this thing called an Oort cloud. And these are just such fun words to say. I feel like just learning these for the words alone is fun. Oort clouds is a thick bubble of icy debris, icy chunks that surround our solar system. And so as you move away from the sun, you can kind of see some of these other things that we've seen here. So between Mars and Jupiter, here's this asteroid belt that we were talking about. As we move further out past Neptune, we get to this Kuiper belt. And then beyond is this Oort cloud. And it also, the way that we can kind of look at it is this bubble that surrounds our solar system. Pretty amazing. All right, so let's go ahead and go down to your final slide here and something to just help you process. Again, something that we're going to discuss during our class meeting on Monday. I want you to kind of create an analogy in a way that you can think of organizing the different kind of levels of order within the universe. So here's an example, okay? So here we have some of the different things that we've talked about, and we're starting from smallest and going up to biggest or largest scale. And so we want to kind of think about an analogy that can help us to remember the order of these different sizes. And so we've got planet, solar system, galaxy, galaxy cluster, a cluster of galaxies, and then universe. So here is one analogy. This was taken from another teacher, by the way. So this is Miss Daly's or this other teacher's analogy. And then you're going to create your own. So if we think of our home, where you live, as your planet, then you can think of the solar system as a neighborhood. So think about your house or where you live exists within a neighborhood. Your neighborhood exists within a city. Then if we want to take it a step further, well, your city is a part of a state. So, there's actually a number or a cluster of cities that exist within a state, just like there are a number of galaxies that exist within a galaxy cluster. And then if we want to expand out even further, then these states or galaxies are going to exist within the larger universe. So this is just an exercise that we can do to kind of process and arrange these types of things in our mind. And so let this be a little activity that kind of helps you picture or imagine what's happening here and come up with your own analogy. And I'm very excited to see what you come up with. So this is a little overview of the size and scale of our universe. We've only scratched the surface here, and there's so much more to explore. So now go into your web quest and check that out and keep following wherever your curiosity takes you. This is, like I said, such an enormous topic. So there's tons to learn out there. Have fun and enjoy. Bye.